Today we're going to look at section 5.4, which is it's called more trig functions, but we're really looking at the graphing of these trig functions. We will not spend nearly as much time on this section as we did with sine and cosine. So we're going to look at the graphs. You do need to know the difference between the function graphs. We'll graph one or two, but not any with severe transformations. And that's about it. So there will be some kind of question relating to these on your test, but it's not going to be a huge emphasis. So here we have the four graphs. So we have tangent, cotangent, cosecant, and secant. Now I'm going to focus on tangent. It's really the only one we're going to spend a little more time on. But tangent, if I zoom in there, you can see that it has a period of pi. So from negative pi over 2 to pi over 2, that's a distance of pi, and then it just repeats every pi. So the reason it's doing that is that when we look at, let's look at our unit circle so we can look at these values, but at pi over 2, for instance, why does it have an asymptote? Well, let's go to the unit circle, and that's at pi over 2, which is going to be right here. And at pi over 2, we have the coordinate 0, 1. So we have cosine, I'm going to change those to t's though. So this would be cosine of t and sine of t. And so cosine is 0, sine is 1. So the tangent value there would be tangent of pi over 2 would be 1 over 0. So that's an undefined function. If you have a 0 in a denominator like that, you're going to have an asymptote. So that's going to happen at any place where you have a 0, 1 coordinate. So that will happen at pi over 2 and 3 pi over 2. So at 0, negative 1, it would be negative 1 over 0, would be tangent. So again, it's undefined. So this one has a shorter period, and then it has asymptotes at pi over 2. So that would be tangent. And the same thing's going to happen, the reciprocal function. Cotangent has a very similar feel to it. That period on that one is still pi. So those are the characteristics of those. What we're going to do next, I'm going to go into Desmos, and then we'll just look at some graphs of cosecant and secant, and I will demonstrate the reciprocal functions, sine, and what they look like when we graph those together. So let's do that. Okay, so if I have a sine wave here, that's just sine x, and what I'm going to do is graph its reciprocal function, which is cosecant. And so there's cosecant x. And I'll just zoom in on the first quadrant. And you can see here that cosecant is going to create these parabolic shapes, and it is at pi over, I know this scale, I can't write on this scale, but where it's touching at the peak of sine and at the lowest part in sine, that is at the value pi over 2. So pi over 2, you're going to have these lines that just touch at one place. So that would be sine and cosecant. And then if I look at cosine and secant, they're going to look very similar. They're just shifted over. So there is cosine, and here is secant. So it's the same basic thing. It's just shifted. It's got a phase shift. So if I graph all of those together, you can see they're just slightly out of phase. That's about it. So we're not going to spend tons of time graphing these, and the reason we don't is that they don't come up too often in application problems that you'll deal with. So I don't want to spend all of our time here when sine and cosine do come up constantly. So let's go ahead back here, and I will, let's do an example. So cosecant and secant have a period of 2 pi. So let's work with one of these. So another thing, tangent, this is something I didn't talk about. Tangent doesn't have an amplitude. Now, if it had a number out here, let's say it had a negative 1, for instance. So this one is negative tangent of 2 times x minus pi. We don't call that an amplitude. So we would call that a vertical stretch factor. That's because it's not like sine or cosine where it has a bound at 1 or -1. It actually goes to infinity and negative infinity. So we don't call it an amplitude. So let's look at this one though. We can do pretty much the same thing that we do with sine and cosine. We have a negative sign that's going to flip tangent around. Let's find our period. So in your textbook, they don't even ask you for anything but the period. The period here would be pi over k and pi over 2. So it's pi over k instead of 2 pi over k because the period is only pi. So the period here is going to be pi over 2. Normally, so what I'll do is I'll sketch out tangent here. And tangent, I'm just taking, from this, I'm just going to create that sketch again. These are hard to draw, so I apologize for what it looks like. So you're going to have these asymptotes. So what I'm going to graph right now is just tangent. So I'm going to ignore my function just to show you that. So I will try to get this right. So I'm going to draw my line there. And then that's just going to repeat. So it looks kind of like a cubic. Okay, so that would be tangent of x. So if I look at that one, the period for tangent of x is pi. My period is going to be half of that. And I'm going to have a shift. So mine is shifted over, let's say the phase shift. That's one thing I will need. My phase shift here is pi. So it's going to be pi units to the right. The negative sign out front will flip it over the x-axis. And so what I'll do is create this graph again. I'm going to move these things out a little bit. And now I'll graph my new function, my negative tangent of 2x minus pi. Okay, so the period is pi over 2 and the phase shift is pi. So I'm going to take what starts at 0 on the tangent graph, I'm going to shift that over pi units. So my new intercept point would be at pi. And then on either side of pi, we're going to have, so pi, this would be pi over 2. And then on this side, this would also be pi over 2, if I'm using this consistent scale, or 3 pi over 2. And mine only has a period of pi, so in between that, it's going to be where my asymptote values are. So I will have these asymptotes right there. And so my function would look like a reversed cubic. So these are really tough to draw, which is another reason I don't want to spend tons of time on them. Okay, and if I were to continue this pattern, so I'm going to put one there, here. And then I'm going to draw that same shape again, that reversed cubic. And you can draw those, you could draw 3, 4, however many you want, but one cycle of it would just be one of those red lines. So this would be y equals negative tangent of 2 times x minus pi. You can probably see right now why I don't want to spend tons of time on this. These are really messy. They're even harder to graph than sine and cosine as far as accuracy. So what we're doing is just showing that they exist right now. We'll look at a few of them and then we'll just move on.